Hi everyone. Today I'm going to be talking about dividing exponents with the same base. So here we have a problem v to the ninth divided by v to the seventh. Okay? And I'm going to talk about what does this really mean. Well, up in the numerator, v to the ninth is really v times v 9 times. Okay, so I'm going to write all of that out. Divided by v to the seventh, which is just v times v 7 times. Okay. And we know that anything divided by itself is just 1, so this just cancels out. And you'll notice that we can do this for 7 of them. And so what we're left with is just v times v, which is v squared, or v to the second power. Okay. Now, some of you may have noticed this, but this is not a coincidence, but there's a shortcut to this kind of thing here that we're doing. Whenever we're dividing exponents with the same base, in this case, our base is v, and our exponents are 9 and 7, we can just keep our base, so v, and then take the exponent up in the numerator and subtract it from the exponent in our denominator. And you'll notice that we get v squared. Okay? So that's another way of thinking about it. That's a shortcut way of thinking about what we're really doing here. So let's put that in. Here's another problem. So here this time we have g to the negative 3 divided by g to the fifth power. Now if you think back to our shortcut from our first problem, right? Our common base here is g, and our exponents are negative 3 and 5. So what we're going to do is we're going to keep our base, which is g, look at the exponent in the numerator, which is negative 3 in this case, and we're going to subtract it by the exponent that we see in the denominator, which is 5, and we're left with g to the negative 3 minus 5, which is g to the negative 8. Okay? But we're not done because the question says simplify and express your answer using positive exponents. Okay? Does our answer have a positive exponent? No, it's negative 8. Okay? And so another way we can express this negative exponent is just write it as a fraction. So g to the negative 8 is the same thing as 1 over g to the 8. Okay? You basically remove that negative and then you kick it down to the basement. Okay? That's how I like to think of it. Okay? So let's put that in and see if that works. So you're going to want to click the fraction button. 1 over g to the 8th. Okay. Here's another problem. This time we have q to the negative 9 over q to the second power. Again, I'm going to use that shortcut that we did earlier. Q, our common base is q. I'm going to look at the exponent in the numerator, negative 9, minus the exponent I see at the bottom, 2. And so we have q to the negative 9 minus 2, which is q to the negative 11. Okay? All right. So we have q to the negative 11th. But wait, right? If you read the question, always read the question. Simplify. Express your answer using positive exponents. So, right, we're gonna remove that negative, right? Imagine it's positive, and then we're gonna write it as a fraction. 1 over q to the 11th. Okay. Another way to think about this is like if you have a negative exponent, um, you can kind of imagine it tilting it up into like a 1 up here, 1 over, right? So we have q to the negative 11, right? So that negative sign tilts up to a 1 over q to the 11. Okay. All right. So let's put that in and see. Fraction 1 over q to the. Whoops. Gotta press that exponent bar. Here's another problem. This time we have r to the 0 divided by r to the negative 8. Okay. You'll notice that our common base is r, so I'm going to write that down. And then I'm going to look at the exponent in the numerator, which is 0, minus the exponent that I see in the denominator, which is negative 8. Okay? You want to be careful here because whenever we're subtracting by a negative number, that's the same as adding them. So this is really r to the 0 plus 8, which is r to the 8. And our answer has a positive exponent, so that is okay.